While graphing, have you ever noticed that there are common patterns in equations?
Today we are going to discuss what they are and what they do.
In the square root function, the original overlap pattern is 1, 1, 3, 1, and 5, 1. It changes to 4, 2, 12, 2, and 22. This is because of the vertical dilation. 1 times 2 is 2, 1 times 2 is 2, and 1 times 2 is 2. And the horizontal dilation, 1 times 4 is 4, 3 times 4 is 12, and 4 times 5 is 20. In this graph, there's a scale factor of 2. We can see the original square root function go over 1, up 1, over 3, up 1, and over 5, up 1. Then, in the new equation, since there's a translation of plus 3, it starts at 3, and then since there's a vertical reflection, we flip it. Then, because of the dilations, the new equation makes over 4 down 2, over 12 down 2, and over 20 down 2. This is seen when we go over 4 down 2, over 12 down 2. And then if the graph was bigger, over around here, we would see over 20 down 2. Okay. Carpenters, architects, and engineers use the square root function in their jobs every day.
In the parent function of an absolute value equation, we see on the graph as it goes over on the x-axis 1, it goes up on the y-axis 1. When this new equation that we see down here, we see as it goes over x on twice, then it goes up on the y-axis 3 times. This graph represents the parent function, which is this one right here, and then the new equation that we just saw. See, in the parent function, since it's an absolute value, it will never go below into the negatives on y, because the absolute value of makes it so you can never have a negative, so -1 would always be +1. But because of the equation, we see at the very end, it says -4, so that means the y-intercept would be -4, so that's where the starting point is. And we see a vertical dilation of 3, which is why it goes up 3, and then a horizontal dilation of 2, which means it will go over 2. And then it will follow the same kind of pattern like the parent function, where it goes out in both ways equally. Absolute value is used in real-life situations when determining the difference in speed and distance, because those kinds of equations need to have an answer that will not have negative numbers in it.
In the parent quadratic function, we can see it goes over 1, up 1, over 1, up 3, over 1, up 5. In our new equation, this minus makes a vertical reflection, and this 3 is a vertical dilation. This is seen when we go, instead of up 1, down 3, because 1 times 3 is 3, and it goes down because of the reflection. Then it goes down 9, because 3 times 3 is 9, and then down 15, because 3 times 5 is 15. And then in the horizontal dilation of 2, seen right there, it goes over 1, over 2, over 1, over 2, over 1, over 2. In the parent quadratic function, we can see the overlap pattern that we discussed earlier shows over 1, up 1, over 1, up 3, over 1, up 5. In our new equation, since there was a vertical reflection, it's upside down, and with our dilations, we have over 2, down 3, over 2, and down 9. Quadratic is used when making parabolas, which are also used for finding the distance of arcs when throwing a ball or any other object. We chose this topic because transformations showed up in many parts of our units and is a key concept in Algebra 2.
It was introduced and played a major role in Unit 1.
We also used it when graphing polynomials in Unit 2.
And during Unit 4, when we were learning about graphing, logarithmic, and exponential equations.